So this video is about trigonometric function sketching. We'll first be graphing sine using amplitude, period, phase shift, and vertical shift. And then later on I'll show you how to generalize this into all 6 trigonometric functions. So I find it's best to dive straight in so you can see the parts in action. I chose this problem because you have all 4 parts you need. Y equals 3 sine of 2x minus pi plus 1. So your first step is to find the vertical shift and amplitude. The vertical shift is represented by d on the outside of the equation. It's the vertical start point of where the graph begins. Our problem has a plus 1 at the end, so we add a 1 right here. Our amplitude is represented by this 3, which is how far the graph goes from the center. So the distance between this 1 and the highest point here is 3, which gives you 4. And likewise for down here, which should give you negative 2. Your next step is to find the phase shift. The phase shift represents the horizontal start point of the graph. Now, there's a bit of controversy regarding the phase shift because different textbooks teach different things. So for example, you might see bx plus c, in which case your phase shift is negative c over b. Or you might see bx minus c, in which case your phase shift is positive c over b. But I find the best way to deal with this is just to ignore the sign and set the inside equal to 0. This way you don't have to worry about what sign it is. So likewise for this problem, 2x minus pi equals 0, which gives you pi over 2. So next is the period, in which case you look at the coefficient in front of the x. In our case, the coefficient is 2, so you do 2 pi over 2 to get pi. So that pi represents the distance between the start and the end of the graph. And because of that, you would do pi over 2 plus pi to get 3 pi over 2. So all the hard parts of the graph are done. All you have to do is sketch. I should add one more thing before you start. Each sketch is divided into quadrants, and the fastest way to get those quadrants is to first take the endpoints of the interval and then chop it into halves, and then take those halves and chop it up into quarters. So for example, pi over 2 plus 3 pi over 2 divided by 2 will give you pi, which is the middle. And then you do the same process for the other 2 intervals. So pi over 2 plus pi divided by 2 will give you 3 pi over 4. And then same thing over here, it will give you 5 pi over 4. And then here you finally sketch. This is the first time you look at whatever trigonometric function you have. In this case we have a sine, so we know a sine goes like this. Also keep in mind that if you have a negative in front of the 3 here, this would reflect the graph. So instead of going this way, it would go this way. Okay, now I'll show you how to generalize this into all 6 trigonometric functions. So you would normally start the process using the same method we did before, with steps 1, 2, and 3. The only difference is step 4, the sketch. From here, everything repeats the same process. We still use amplitude, vertical shift, phase shift, and period. And it's the same for all 6. Sine we already know from before. Cosine looks like a U. I'll do cosecant next, since cosecant is 1 over sine. So whatever sine function we had, we have to invert it, like this. Also, since sine is in the denominator, we know that whenever we have a 0 in sine, that would become an asymptote in cosecant. The same logic applies to secant. Secant is the same thing as 1 over cosine. So you would just take the cosine function and invert it. And whenever we have a 0 for a cosine, that would become an asymptote for secant. So tangent is the same thing as saying sine over cosine. And just like before, since cosine is in the denominator, that's when you have asymptotes at tangent. So the general shape of tangent is that it's always increasing. So you draw the function going up. And the same thing for cotangent. Cotangent is cosine over sine. So whenever sine is 0, that means you have an asymptote at cotangent. Also, cotangent is a decreasing function, so you sketch going down.